Officially the dimmest constellation in the sky, Mensa seems completely empty and lifeless to the naked eye. But it is the only constellation in history named after a real geographic object on Earth. This celestial monument serves as an eternal granite pedestal for a colossal galaxy, the Large Magellanic Cloud. And in its absolute darkness lurk quasars shooting plasma jets for hundreds of thousands of light years.
Today, we're going to delve into the constellation Mensa. Now, on the surface, it might not seem like much, but it offers a truly profound lesson in cosmic perspective. You see, Mensa holds a rather unique distinction. It is, officially, the faintest constellation in the entire celestial sphere. None of its stars are brighter than the fifth magnitude, which means that to the naked eye, it's practically invisible unless you are in the absolute darkest of skies. So you have to ask, why would we dedicate an entire analysis to a constellation that's pretty much defined by its own emptiness? Well, the answer lies not in what Mensa is, but in what it supports. Our investigation today will unfold in 5 distinct parts. We'll begin with this central paradox, then we'll map out its astronomy, uncover its astrophysical secrets, explore its unique history, and finally conclude with its really profound symbolism. So let's start with that central paradox. Is Mensa just a celestial void, an empty patch of sky, or is it something more? Perhaps a cosmic pedestal? And here is the crucial point. Mensa's very faintness makes it the perfect dark celestial stage for one of our own galaxy's most brilliant companions, the Large Magellanic Cloud. In a way, its emptiness is its entire function. All right, let's move into our second section, astrometry. This is the science of precisely measuring the positions and movements of celestial bodies. Here, we're going to define the physical space that Mensa actually occupies up there. Mensa covers about 153.5 square degrees of the celestial sphere. To put that into perspective, it ranks 75th in size out of the 88 modern constellations. So it's pretty modest, both in its brightness and in its physical area. Because it's located so close to the south celestial pole, Mensa is really an exclusive feature of the southern hemisphere. For observers in most Europe, North America, or Asia, it simply never rises above the horizon. The best time for our southern observers to try and spot its faint stars is during December and January. Now, for anyone observing from places like Australia, South Africa, or southern South America, Mensa is what we call circumpolar. And that just means it never sets. It's in a perpetual circle around the south celestial pole, a constant, if very subtle, presence in their night sky. Okay, so let's shift gears now. We'll move from what we can barely see with our eyes to what we know through our instruments. In this astrophysics section, we are going to use the power of modern astronomy to reveal the truly extraordinary objects hidden within Mensa's borders. Let's start with Alpha Mensae, the constellation's brightest star. What's fascinating is that it's remarkably similar to our own sun. They're both yellow dwarfs with very similar mass and temperature. And yet, because it's 33 light-years away, Alpha Mensae appears to us as just a barely visible speck. It's a very powerful reminder of the sheer scale of the cosmos. And if we look even deeper within Mensa, we find the star system HD 39194. This was discovered back in 2011, and it hosts 3 confirmed super-Earths. These are hot, rocky planets that orbit incredibly close to their parent star. But the most extreme object hiding within Mensa's borders is, without a doubt, the quasar PKS 0637752. This isn't a star, it's not a planet, it's the hyperactive nucleus of a very distant galaxy, an object of almost unimaginable power. So, what is the engine driving a quasar? Well, at its very heart is a supermassive black hole. As gas and dust and stars spiral into it, they form the spinning accretion disk, which gets heated to millions of degrees, glowing brighter than its entire host galaxy combined. And this incredible process powers the ejection of these colossal jets of plasma from the poles at nearly the speed of light. The scale of this phenomenon is just staggering. The Chandra X-ray Observatory detected the jet screaming out of PKS 0637-752 and found it to be hundreds of thousands of light-years long. That's many times the diameter of our own Milky Way galaxy. And this entire cosmic engine is contained within the borders of the dimmest constellation in the sky. So, having examined its physical nature, let's now turn to Mensa's human story. How did this faint, unassuming patch of sky even get a name and a place on our celestial maps? Well, it's a story of science, of exploration, and the very spirit of the Enlightenment. The constellation was actually created by a French astronomer, Nicolas-Louis de Lacaille, during his expedition to the Cape of Good Hope in the mid-18th century. He named it for the famous Table Mountain that completely dominated his view. The name was later Latinized to Mons Mensae, and then eventually it was shortened to its modern, simple form, Mensa. Lacaille's own words really reveal his motivation. He said he wanted to immortalize this place in the heavens. You see, he wasn't just cataloging stars as points of data. He was deeply moved by the grandeur of the landscape where he was doing his work, and he wanted to place a piece of that Earth up in the heavens. And this gives Mensa a truly unique historical distinction. I mean, think about it. Other constellations are named for mythological figures, gods, beasts, or scientific instruments. Mensa is the only one named for a specific real place on Earth, Table Mountain in Cape Town, South Africa. So for our final section, we're going to synthesize the science and the history to really understand the powerful symbolic drama that Lacaille so deliberately crafted in the southern sky. The symbolism is this incredibly elegant, direct parallel. On Earth, the physical Table Mountain is often draped in a layer of clouds, a local phenomenon known as the tablecloth. Lacaille, with an artist's eye, noticed that his celestial Table Mountain, the constellation Mensa, was positioned directly beneath the Large Magellanic Cloud. So what he did was essentially create an eternal celestial art installation. He used the stars themselves to draw a mountain and then intentionally placed it permanently beneath a galaxy that looked like a cloud, perfectly mirroring the scene he saw every day on Earth. He fixed a transient, beautiful terrestrial phenomenon into the permanence of the celestial sphere. You see, this celestial drama is so different from the ones that the ancient Greeks gave us. This isn't a story of gods or mythical beasts. It is a quiet, profound celebration of the Age of Enlightenment. It's the story of a human explorer, observing, measuring, and bringing a human sense of order to the cosmos. And so we conclude there. Mensa teaches us a vital lesson, that significance is not always about brightness or prominence. It makes us wonder, doesn't it? What other seemingly empty, modest pedestals in science are just sitting there, waiting for us to discover the great structures they so quietly support?
Thank you, friends. Strive for understanding and become wiser. See you soon.